The year is 2030. The year is 2030. A group of people have been selected by a few space agencies all over the world to go to be the first humans on the surface of Mars. They board a SpaceX Starship that launched the year before, in 2029. They arrive at the red planet and make a soft touchdown on the surface. And the commander of this mission takes the first human steps on another planet. And she makes a comment about the importance and grandeur of this step. Okay. She and her colleagues, of which there are 12, spend 2 years on the surface of Mars doing research about how to build long-term settlement. They live inside the Starship for those entire 2 years using EVA suits to go outside, collect samples and so forth, using the onboard science lab, and using the food and water that was delivered 2 years earlier by a fleet of 6 other starships that delivered cargo to the surface in the same landing area on the surface of Mars. They make some discoveries about permafrost and soil, and when their 2 years on the surface is over, they get back on their starship that has used the carbon dioxide atmosphere and the water in the soil to make methane and liquid oxygen so that they can return back to Earth. And they launch back off toward Earth. 3 years later, another mission launches to the surface of Mars, this time with a host of other cargo spacecraft that are carrying with them 3D printing machines that make permanent habitats on the surface. These are 3D printed homes. These are 3D printed homes that use the Martian soil called regolith and a plastic that has been made out of corn here on Earth. Combine the two on the surface of Mars and print these egg-shaped permanent homes. These are the first permanent human structures to be built for habitation on the surface of another planet.
That's pretty big.
Okay? These astronauts plan to be on the surface of Mars not for 2 years, but something more like 10 years. Living and working. This time there's not 12, there are 40. 40 astronauts that have dedicated themselves to a 10-year-long mission to make a permanent footprint for humanity on the surface of Mars. This time they bring with them surface roving vehicles. They bring with them large-scale energy production infrastructure. We're talking about large solar farms and large wind farms. They also use some nuclear reactors when those two other sources of energy do not supply enough. After those 10 years, or during those 10 years rather, more and more settlers are sent to Mars. And this time, they are not simply going to stay for a few years, but for the rest of their lives. These settlers bring with them expandable habitation units that include greenhouses and food and fuel processing units that will stay forever on the surface of the planet. These are scattered amongst the 3D printed homes, and we are starting to see a large-scale human presence in the way of about 200 to 400 human beings living on the surface of Mars. The year is 2044. Yeah. The water? Oh yeah. So the government that this colony establishes for itself is not a government of any nation back on Earth, but their own Martian direct democracy, where each member of the colony votes on every potential law or policy. Not a republic, a direct democracy. There is no representation. There are no representatives. There is simply direct democracy. Each member of the colony votes on each policy and law proposal. Amongst a bunch of people. Could this be difficult? Yes, but it will be difficult in the future, less and less so. When voting on a policy decision is as easy as voting on a Twitter poll, this is going to be really easy to do because we are all connected already. And remember, this colony only has the population of a few hundred. Okay? So there's no mayor, there's no president, there's no representatives, no city council. This is simply a direct democracy. Each person has a say in what is done, equal to every other person. Okay? Now, we see that these colonies start to expand, and 2044 marks a time when humans really ramp up the speed at which they start the colonization of Mars. They begin to make large 3D printed and Martian, so using only Martian materials that are not coming from Earth anymore, but simply from Mars itself, to make large domes that are pressurized. How do you 3D print it? Yeah. You grow a whole bunch of corn in your greenhouses, and you use that corn to make plastic. Then you combine that plastic with the Martian soil. The plastic is made out of oil, but we can make an oil out of corn that is equally as useful. Yes, Aiden. Yeah, surviving Mars is a pretty dang good analog for what's going to happen in the future. Yeah, I mean, that's fine. You can for your colonization story, if you want to make this as a story, kind of like an essay, that's a great way to do this. You can put in you can take some artistic liberties. Instead of having something futuristic and very polished and finished, you can, I don't know, change the material we use into these scrap. Yeah, like the scrap metal. Yeah, the humanity barely survives just by the grit of our teeth. Yeah, I mean, that's totally fine. Sam?
But I mean, like, how do you get a 3D printer big enough?
A 3D printer big enough?
Yeah.
Well, the printer itself doesn't actually have to be that big. the mechanism that it is put on has to be that big.
So
So
it prints a bunch of tiny things?
no. You make a track for it that's big enough to print an entire dome.
Oh, I
Okay, so this is 2044 is when humanity really ramps up its colonization efforts. By 2050, there are not a few hundred people, but over 10,000 people living on the surface of Mars. By 2050. Now we start expanding our city. Now we have started to make multiple cities that sprawl across the Martian landscape, completely enclosed, obviously, but the thing is that we are not that far from having completely enclosed cities already here on Earth. We just allow for open air between portions of our buildings. Yeah.
So with these 10,000 populations, all rock from Earth, or it's not going to be much more?
Right now, 2050, all 10,000 people that live on the surface of Mars are all native Earthlings, all native Terrans. A bunch of research has been done over the past 15 years on the surface of Mars to investigate the influence of low gravity on pregnancy in placental mammals. From increasing size of mice to rats, then to rabbits, sheep, and then finally to pigs. All of these seem to be working okay if the mother spends time in a centrifuge for a few hours every day.
what's the centrifuge?
A centrifuge generates artificial gravity. Okay?
What does that mean?
So they find that each of the placental mammals that is pregnant needs to spend time in a centrifuge for the normal development of the embryo into the fetus, and then finally into the newborn child. Experiments have gotten to the point to which the Martian governing government, the Martian governing body of the people, the people's state of Mars, have allowed for the first human birth, and the first human trials at birth on Mars have been approved in 2052. 2052, the first few tests on human birth on Mars go relatively well, but unfortunately the first Martians do not live very long. They're simply not strong enough. So the scientists increase their efforts to determine how artificial nutrients and gravity can be implemented to ensure a healthy birth. And in the year 2054, the first human is successfully born and survives to adulthood as a Martian.
So we would call them Martian.
So they do research the Martians now. Yay.
Okay, the first human Martian is born that will live to adulthood in 2054. By the year 2070, cities on Mars have grown so that instead of multiple interconnected bubbles of city, we now have entire cities that are encapsulated in their own pressurized spheres, pressurized domes.
What does the atmosphere of Mars look like now?
What does it look like right now?
No, what is the atmosphere?
The atmosphere of Mars is extremely thin. It has an atmospheric pressure of only 0.09 atmospheres.
Is that far into the future of my job?
Yeah, even at this point, the mid 2050s, to early 2060s, the atmospheric composition of Mars has not truly changed all that much because humanity is focused on colonizing Mars as it is and not changing Mars to fit our needs. Terraforming has not truly begun.
When does terraforming start?
So now we have a time in the mid 2060s when humanity has started to expand its footprint even more. Now in 2065, the population of Mars passes 500,000 humans. 500,000 humans in 65? 2070? Yeah, 2065, 500,000 humans living on the surface of Mars. And by 2090, the population of Mars has passed 2 million. Okay? This is when terraforming truly starts. Humanity has already expanded its footprint beyond Mars out to the outer solar system and has started collecting comets in the Kuiper belt to bring into the inner solar system and hit Mars at its poles with these comets. That would rise the temperature.
What will these comets do? Like, what will they have on them?
So the comets are primarily made out of water ice and volatiles like nitrogen and oxygen, with some dirt and carbon and metals sprinkled in. But humans in the outer solar system have selected the most oxygen and carbon dioxide and water-rich comets to fling toward Mars in order to change its atmosphere in a atmosphere and its terrestrial biome even more. Okay. Now we're going to jump farther into the future.
How much damage can a comet bring to a planet?
Huge amount of damage. A comet can devastate a planet, but if you hit Mars at its poles, where humans will not be living on Mars, the humans will be fine. The humans will be fine. We just need to make sure that we are precise in the way that we do this.
Does Mars, Mars rotation around the sun change their own?
No, so Mars's orbit would not be affected, nor would its rotation. A comet can devastate something living on the surface of a planet, but to the planet, it's like a flea trying to take down a blue whale. Elijah and then Aiden.
So how where do we get all this material from? Material we have.
What material?
Like all the, well, it looks like these kind of metals, I see glass.
Yeah. So glass is made out of sand, right? Plenty of sand. The majority of the regolith on the surface of Mars is made out of ferrous oxide, iron. We can make steel out of that. So we make steel out of the Martian dust. We make glass out of the Martian sand. We do the same thing that we've been doing here on Earth. Earth and Mars are very similar in composition. I've got to go to Aiden, then I'll get to everybody else. Yeah, Aiden.
So, surviving Mars is actually fairly accurate.
Surviving Mars is quite accurate. If you don't know what Aiden's talking about, Surviving Mars is a game that can be played to simulate how humanity might colonize Mars. Repeat and then Franklin.
So on Enceladus, because the ice crust is pretty much just water, is there like any accessible like resource that you use to like build structural supports and whatnot.
So Enceladus has a core.
Yeah.
And that core, Enceladus has a metallic and rocky body underneath its oceans. In order to get to those, you'd have to go through the ice, through the water, down to the rocky metallic crust underneath all of that.
Probably take a little bit.
That would take a wee bit of time, but also a lot of energy, but it's not unthinkable. Franklin, you had something?
How long are days?
24 hours, 48 minutes. Very, very similar to Earth.
As far as it's
The solar day here on Earth is 24 hours. The sidereal day, which is how much it takes for any particular star to rise in the sky, is 23 hours, 54 minutes. Okay, so humanity has started to terraform the surface of Mars. After 300 years of this intense terraforming efforts, and unfortunately several hundred deaths from accidents during the terraforming process, humanity has managed to transform Mars in as much that it is able to sustain liquid water on its surface and increase the atmospheric pressure to about 30% that of Earth. It is still primarily carbon dioxide, but that is good. It keeps the planet a little bit warmer. We have now a blue and red Mars, a blue and red Mars. That's after, what did I say, 200 years? 300 years of terraforming. After an additional 1,000 years of terraforming, we are now in the year 3,460. 3,460. The surface of Mars does no longer resemble a barren red wasteland, but a blue and green expanse. The northern hemisphere being primarily covered in an ocean, the southern hemisphere being primarily covered in a green wetland. Many highlands near the Tharsis region, which is where the Olympus Mons, the largest volcano in the solar system. Highland regions that don't have any vegetation, but the lowlands are covered in marshes, riverbeds, plains. This planet begins to look much like its neighbor closest to the sun. Now we no longer have one green and blue planet, but two green and blue planets.
And we can put parallel.
And we what?
And we can put reindeer on Mars.
And we can put reindeer? Is that what you just said? Yeah.
What's it called when there's like gardens that like there's like super hydroponic gardens?
Hydroponics. Yep. Philip.
Because the planet's smaller than Earth and the gravity is way lower, it makes like some super trees, like super awesome.
So if given a few million years of evolution on Mars, yes, the trees would be taller.
How do they expect
They'd be taller and less robust in their trunk. So they'd be thinner. They'd be thinner but taller. Animals would also evolve in a similar way to be more small, like their bones and muscular structure would become longer. They would become less, like a bear. Right now, bears are very stocky. After a few million years of evolution on Mars, bears would be more dog-like, right? Their limbs would be longer. Their Their bones would be thinner. Their muscles wouldn't be as.
Would that be the same case for Martians, or would it go out?
Humans by this time have mostly moved beyond biology. By this time, humans are mostly artificial. Well, because there's no reason to be biological if you don't have to be.
What does that mean?
So, what I mean is you replace your meat bits with metal bits. So you replace the meat pump in your chest with a metal pump in your chest. You replace the oxygen processing units that are in your chest that are made out of meat into a synthetic plastic and metal combination of an oxygen processing unit. And you replace the meat computer in your skull with a silicon computer in your skull.
How much of our humanity will we lose?
What do you mean your humanity? Your humanity,
Depends on like the
Personality.
you don't have a body, you are a body. The entirety of your humanity is chemical reactions in your meat computer. If we can perfectly replicate those chemical reactions in electric reactions in a non-meat computer, in a silicon-based computer, you are still human.
and still you.
And you are still you. You are simply not biological. Franklin?
But for like, in a million years, animals would start like, is that a no on the radio? Maybe not.
Is that no one to read here?
Maybe not introduce our elements from Earth.
I think that it would be actually important that we seed life from Earth onto Mars,
So like,
because the timeline that it would take for Mars to develop its own biology would be on the scale of billions of years, and we don't have that much time. The sun only has about 4 billion years left.
basically just start like, develop something.
So what we need to do is we need to make a bunch of trips between Earth and Mars, carrying animals, plants, microbes from Earth to Mars.
Operation Noah's Ark.
Operation Ark, yes.
Can we just do it?
We cannot move the Earth. Elijah,
What would the UV index be like on the low end of Mars?
the UV index,
Yeah.
it'd be low.
Like lower than Earth,
It'd be lower than Earth, yeah.
because it's further away from the sun.
It's further, yeah, it's further away from the sun, and that if you get a similar atmosphere on Mars, if you get a similar atmospheric pressure and atmospheric composition that we have here on Earth on Mars, because you're farther away, it would lower the UV index.
More like
We would.
less than a year.
At this point, we need to start putting our electromagnet in between Mars and the sun in order to maintain the atmosphere, because there is no magnetic field around Mars. Yeah.
That generates that uses heat to generate electricity.
Thermoisotope radioactive. The thermoradioisotope generator. There we go.
Is that
Yeah, Phil.
You've seen the timelapse of the future. We think we could avoid that future and survive on cylinder.
Survive on a what?
On a cylinder. A huge thing that's like a planet converted on itself.
Oh, I don't know. O'Neill cylinder. Time lapse of the future. I'll talk to you later about that. That's a good idea. Okay. This is the end of our story. All right. We have taken Mars from a barren red wasteland to a lush green, blue and white marble. This has been achieved through human ingenuity, science, and engineering. But first, we had to have the imagination to do it. And to have that imagination, not only do we need science and engineering and math, we also need art. We need to be able to envision this future. And all of the pictures that I just showed you today are essentially what I want you to be able to give to the art program. Not that picture. I want you to be able to give those ideas to the art program so that they can make something that envisions a future like this. Okay? That's all I have for you. Do the colonization final assignment. We'll work on that for the rest of class. Like and subscribe or whatever.